Hello, Trig Pre-Calc students. So today we're taking a look at section 1.4, shifting, reflecting, and stretching graphs. So this is all of those transformations that you covered a lot in Algebra 2. So that being said, we're not going to get carried away and go on forever about all of this. We're just going to kind of do a quick little refresh of just some of the highlights that we expect you to know when we take a look at some of the graphs. So first up, grab your graphing calculators and let's get to it. Graph the function f of x equals x squared on your graphing calculator, and then of course we're going to graph these other functions and compare them. Now we should all recognize this f of x equals x squared is our quadratic, it's our parent function, it's our plain old boring parabola. So I'm just going to hit graph, take a look at it. So that, of course, 0 squared is 0, 1 squared 1, some of the points on it, 2 squared 4. Let's take a look at graph A when we take a look at this. So in y2, I'm going to type this guy in, x squared minus 3. And let's compare them. So we can see the red one, of course, is shifted down 3 units. You probably remember that from last year, I'm guessing. When you have that minus 3 at the end, it's a vertical shift up or down. I'm just going to say down 3. I'm not going to get carried away. Okay, clearly what's different is they added the 2 here. Some of you might know or remember from last year how that's going to affect the graph, but let's take a look at it. So now I'm going to change this to 2x squared. Clear that out. So just think about this before I hit graph. We go from just 1x squared to 2x squared. So there's our original, okay. So I see, of course, the red one is narrower. It's inside the blue, of course. And if you remember, if you take a look at the T-chart here, I'm looking at those y coordinates. The red y coordinates are all doubled. So that is what we call, if you remember, a vertical stretch. Let's jump that down. Vertical stretch. And I'm going to get fancy here and say by 2. All right, let's take a look at the third one. So things that are different from our parent function, I see we have the negative and the plus 1. Well, you probably have an idea what the plus 1 is going to do, especially after graph A. And the negative, I hope you remember from last year. So let's clear out the second one, and I'm going to replace that with negative x squared plus 1. Let's hit graph. There's our parent. Okay, so our new function, the red one, of course, we have that reflection. Anytime we see a negative, that's a reflection, and let's get specific. We reflected over the x-axis, it flipped. And of course, that plus 1 moved it up 1. So these are all things, of course, we can tell just from the equation. I know it was going to be up 1 from this at the back, and then I knew from that negative in the front it was going to reflect over x-axis. So just a little refresh of some of the different shifting we're going to be seeing today. Now, this is all on the last page of your notes. If you flip in your packet one more page, you will see all of these parent functions. Now, commonly we're going to use our constant function, our horizontal line, our identity function. Remember, that's really y equals. So, of course, the ordered pairs are the same. 5, 5, 7, 7, negative 1, negative 1. That's our identity function. We've seen absolute value. Of course, that's our V shape. Square roots, we've seen that's kind of half of a sideways parabola. We just talked parabola and, of course, cubic down there at the bottom. So if you flip to kind of the back, like I said, flip one more page in your note packet, you will see all of those lovely graphs in there. Okay, things we got to fill in on the notes. Let's get to it here. So horizontal shift, C units to the right. So this is what you need to fill in on the blank on your notes there. Now notice, for horizontal, you're adding or subtracting the value inside the parentheses to x. So next blank, of course, you're filling this guy in. And it's kind of opposite what you would think. The minus c moves it right. The plus c, if you add a value, left. And then we're going to switch. If you fill this in on the blank, if you subtract a number from the back, it's a vertical shift down. If we add something to the back, it is a vertical shift up. So you need to fill in what I circled in blue and red on the blanks on your note packet. All right, we kind of touched on negatives and how that affects the graph, of course. Those are our reflections. So first thing you got to fill in on the notes. We saw this example. When you have this negative in the front, that reflects over the x-axis. Next thing to fill in on the blanks, this guy. When you have the negative in the parentheses attached to the x, that will result in a reflection over the y-axis. Now that's probably not quite as commonly seen as the reflect over the x-axis, but just we should be aware that that's how it does affect the graph. All right, we saw our shifting, of course, in one of those warm-up problems when we had the 2x squared. So first thing you gotta fill in is this guy. Notice C is in front, you're multiplying the function. If your value's over 1, it stretches it. Just like we saw, we went from 1x squared to 2x squared. 2 is over 1, of course, it stretched it vertically. If your value, next thing I'm filling on the blanks, is between 0 and 1, a half, 2/3, a third, a quarter, it shrinks the graph vertically. And we're going to take a look at all of these here coming up at us in a minute. All right, flip the page. So example 1, how would you explain how g of x and h of x are related to f of x? So we're comparing from our parent function here, just for dramatic emphasis, of course, that's a 1x squared. So for g, I see we've got the fourth and the plus 2 added. I'm going to start with the plus 2. That's probably the easiest part. That would be up 2. And then the 1/4, you're multiplying by a fourth. So the fourth is between 0 and 1. So that's our vertical shrink. You can abbreviate too. I'm just going to sneak these in here. I don't have a ton of room. Okay, on the bottom one, of course, we've got the negative and the 1/4 still. So the 1/4 is still going to be the vertical shrink. So I'm going to jot that down again. Because remember, we are comparing this to the 1, the f of x at the top. And then the negative is always a reflection. And I'm going to get specific, the negative's in front, so it reflects over x-axis. Got it, short and sweet. Okay, let's take a look at B. So of course we're looking at our absolute value, our f function at the beginning. Technically we go from 1 to a 2. You're doubling it, so that is that vertical stretch. And you're welcome to say by a factor of 2 if you want to get really fancy about it. Whew, we got all sorts of things in H. Let's just work left to right here. The negative, of course, is going to reflect. So I'm going to say reflects over x. So many things, so many things. The 2, of course, is a vertical stretch again. Vertical stretch. We got it all in this guy. Okay, next up, of course, we've got the plus 2. Now that is in the absolute value brackets with the x, so that changes it horizontally. Plus 2 makes it move right 2. Or sorry, I'm sorry, left 2, left 2. That's what I meant to say. Left 2, opposite of what you would think it is. Left 2, there we go. Left 2. And the easy part, of course, here, -1 makes it move down 1. The back. There we go. And remember, there's really no reason to ever get any of these wrong. Worst case, you could always graph them in your calculator and just compare them to one another. So, in theory, we were supposed to be graphing these by hand. Of course, I do not know if you're typing them all in your calculator. I'm going to do them all by hand, though, of course. So f of x, let's do this one in purple, our parent function, absolute value. So I'm just going to think about a little t-chart just to get the v going. If I put 0 in, absolute value is 0, 0. If I put 1 in, the absolute value 1 is 1. 2, absolute value 2 is 2. Probably get enough points that way. Let's do some negatives. Absolute value -1, 1. Absolute value -2, 2. So there is our parent v function. Now, I'm going to generate the other 2 graphs from this guy. Of course, I don't know if you type it in your calculator, but we should recognize this +4 at the end moves it up 4. So all I'm going to do is go over to my purple v here, and I'm just literally going to count it. I'm going to go each dot, I'm going to go up 4. There we go, up 4. And you can see I'm just working left to right here. I didn't mean to touch it there. Okay, up 4, and the last one up 4. All right, so let's get that drawn. Now, obviously, I don't expect you to be doing these in different colors. I'm just going to label. So that was my g function. This was my f. And of course, I have to do this last one. Let's do this guy in green. Now, we have all sorts of things here. We have the reflection over x, and of course we have the 3 right, because you're in those absolute value brackets with x, so there's a horizontal shift. Obviously this one's going to be a little bit trickier to draw because we have so many things. We also have the 2 in front, the vertical stretch. Whew. So here's my advice. It's hard, I think, to do it all in one. So here's what I'm going to do. I'm going to kind of step by step it. So looking at my purple parent function v, I'm going to start with the reflecting part. So if I just flip it over the x-axis, clearly the origin is on the x-axis still on there. I'm going to flip this over the x. I'm going to flip the far dot over the x2. So instead of 2 up, I went 2 down. Now I'm on the right side here. I'm looking at this point. So I'm 1 up, 1 down. 2 up, 2 down. So that would be the reflection. So that's easy enough. Now I'm going to move it to the right 3. So I'm just going to kind of dash this on kind of a little template, kind of like how I did those piecewise graphs. So now I'm going to go right 3 for each point. 1, 2, 3. 1, 2, 3. 1, 2, 3. Got it. Got it. So I'm looking at this guy. Okay, now I just have to do the vertical stretch part of this. So remember, that means our y coordinates are doubled, times 2. So I'm going to keep, of course, this vertex point at 3, 0, but I'm thinking about, instead of just being 1 below it, you're really 2 below. Now I'm going to be 4 to get the stretch. So there is my final beach function. So my advice, when you have a lot of different transformations to do, is I would do the reflection first. We're just going to erase some of this. Do the reflection first, and then I did the left, right, and then I did the vertical stretch. Do you have to do it in that order? No, but I do think that's the easiest order to do it in. And of course you can check those on your calculator. All right, let's do the next one. Same thing. I'm going to do the parent function in purple. I know it's that square root. It's kind of half of a sideways parabola. I'm just going to do a little t-chart here. A little review on domains. We can't square root negative numbers, so I'm going to start with 0. Square root of 0, 0. Square root of 1, 1. Now we could put 2 in, but that will give me a decimal, and we already know my graphing skills are limited. Let's go to 4. Nice perfect square. Square root of 4, 2. 4, 1, 2. Got it. Now again, I don't expect you to have yours in different colors. I would just label. All right, let's do the next one in red. So of course the plus 1 is with x underneath the square root. So that of course is our horizontal shift, left 1. So I'm just going to take my 3 points here I have on my purple parent function and move them each left 1. Left 1. Left 1. I'm going to draw that. I'm going to label it G. Don't judge my drawing skills. Okay, let's do H in blue. So minus 4 with x under the root, so that's horizontal. It's going to be 4 right. And then of course the plus 2 at the end is your vertical shift, up 2. So I'm going to take that original purple graph. Doesn't matter if you do the upper right first, that won't make a difference whatsoever. I'm going to go 4 right, 3, 4, up 2. 4 right, 1, 2, 3, 4, up 2. And then 1, 2, 3, 4, up 2. Got it. We're kind of on top of each other there. That sometimes does happen. Okay, final graph to do. Now this one, I'm going to be honest, I don't love it because they don't start you with the parent function. Our normal parent function, of course, they're already using f, but we know our parent function is just the x squared, which we already graphed earlier. 0 squared, 0. 1 squared, 1. 2 squared, 4. Negative 1 squared, 1. Negative 2 squared, 4. So I am going to draw that original parent function on, so I'm really going to end up with 4 graphs here. Now this really isn't part of it, but so I'm just going to kind of dash it on and use it as a template. So that's my parent function. Okay, not actually part of the graph yet. Let's do f in red. So minus 2, that's a horizontal shift, 2 right. That's going to be nice and easy. So let's take our parent function here. I'm going to start at 0, 0, 2 right. Then negative 1, 1, I'm going to move that 2 right. and then negative 2, 4, 2 right. Same thing here, 2 right, and then 2 right. Got it. And I'm just gonna label, that's my F. Okay. Let's take a look at G. That doesn't look so bad. Of course, plus 2 to left. And then the plus 2, so many plus 2s at the back, 2 up. Now again, it doesn't matter if you do the left 2, the up 2, doesn't matter, you pick it. And that's from our purple parent function I'm counting. So I'm gonna start at 0, 0, and I'm gonna go 2 left, 2 up. I'm gonna start at negative 1, 1, 2 left, 2 up. Negative 2, 4, I'm gonna go 2 left, 2 up. 1, 1, 2 left, 2 up. And then of course my 2, 4, 2 left, 2 up. Got it. Okay, and let's just label that guy H of X. Final graph. So of course, negative. We've got the reflection. We've got the 2 right. And of course the minus 1, 1 down. Now again, this is all the purple parent function that we are shifting. Now again, I'm going to do it kind of like I talked about earlier. When you have a reflection, I always do the reflection first, and then of course I'm going to do the rest of it, the 2 right, the 1 down. So let's do the reflection of the purple one first. So vertex still the same. So negative 1, 1, I'm looking at this point right here, I'm 1 above the x-axis, so 1 below. My negative 2, 4, I'm 4 above, 4 below. Got it. 1, 1, I'm 1 above, 1 below. My 2, 4, I'm 4 above the x-axis, so I'm going to go 4 below. 1, 2, 3, 4. So there's the, just kind of dash that guy on. So there's the reflection. Now I'm going to do the rest of it. 2 right, 1 down. So I'm starting at the vertex, 0, 0, 2 right, 1 down. Negative 1, 1, 2 right, 1 down. I'm trying to draw these points a little bolder. These are going to be my final ones. I'm at 1, negative 1, 2 right, 1 down. Negative 2, 4, 2 right, 1 down. And then the last point here at 2, negative 4, 2 right, 1 down. And that's what I'm going to draw on. So even though I've got way more graphs on here than just the 3, we needed that purple parent function to start with, and then I kind of did the last one in 2 steps. I know some of you can do all of that in your head, that's fine. Of course, you're welcome to do the little dash template on it too. As always, you can check these on your graphing calculator, but try to be doing them by hand. Have a great day.